Hi everyone, I'm Amanda.
I'm Anahita.
And I'm Jessa. This is our Math 150 Calc 1 honors project for fall of 2022.
Last semester, a group of honors students illustrated how Snell's law and the principles of least time applied to the movement of dogs between the river and the shore. Our group wanted to test this theory as well to see if it would prove to be true for a multitude of mammals. We decided to experiment this idea on horses in an equestrian field. In order to expand on their work, we analyzed the movement of one pony, a small horse, while training in a round pen. So our question today is, do horses instinctually apply Snell's law to find the shortest distance when different mediums are present? For thousands of years, people have been fascinated by how light takes the shortest pathways from one medium to another. From ancient Huron's shortest distance problem to Snell's law and the principle of least time, we have proven empirically and theoretically that light takes the shortest time to travel from one medium to another. Last semester, a group of MiraCosta honors students illustrated the same principles and theory to the movement of dogs between the river and shore. We are expanding on their work. We gained access to an equestrian facility in Rancho Santa Fe, California, and we conducted research in an arena that had two different soil textures. One was more dense and one was tufted. We used these two different mediums to see if the pony would go at different angles and speeds on the different mediums following Snell's law. Our pony was named Coco the Pony, and we would like to give a special thank you to Rachel, the horse trainer that allowed us access to this horse. We used carrots as the main source of motivation to get the horse from one point to another, and we used 3 iPhones to record all points of action moving from point A to point B. We also used a 100-yard tape measure to measure the pin and the area of the field itself.
The first step that we took to analyze the data was to create a map that displayed all of the data that we collected in our measurements from the experiment. We created this map on AutoCAD and we divided it up into 2 different main regions, marking the different types of mediums, the different soil. We then from there could mark all the pathways that the pony took. So we had 10 different pathways that we marked on the map. And from there we could use the videos and match the timestamps in the videos of when Coco changed pathways with the pathways that we drew on AutoCAD. That allowed us to get the time and the distance for the pathways, so then we could find the velocity. We then found the average velocity of the pathways from all 10 clips. Right here displays the AutoCAD map that we came up with. And then right here you can see the 10 different pathways that we marked out that Coco took. So then here's all the data. So right here is a chart that includes all of the data that we collected. It shows the time, the distance, and the velocity for all of the pathways for the 10 different clips. Right here illustrates the average velocities that we got for the different paths. So you can see that path 1 has a lower velocity than path 2 and 3, and we even saw that there was a p-value of less than 0.05, meaning that there is a significant difference between path 1 and the other 2 paths.
As you can see in these 2 videos, As Amanda just stated, there is a significant difference in velocities amongst the different pathways that Coco went. First video, she took a little bit of time and then went over to Anna. But as you can see in these two videos that Coco did cut at an angle as the mediums changed. So from our research, we did conclude that horses do instinctually follow Snell's law. We see that horses are consistent to the theory, as it took 3 different velocities and pathways on the different mediums. However, the horse is not itself performing calculus notations in their head in order to apply this theory. Instead, they are using the subconscious mind to rely on intuition to find the easiest and shortest path. Our experiment did come with some limitations. The soil mediums were not drastically different. They were both soil, but they had their own densities. Our data is using a pony that was domesticated and trained to be ridden as opposed to a wild horse. And the horse was used to the trainer standing in the middle of the arena, which could have affected the pathways taken by Coco, since the pony is used to not being allowed to go through the center, so she could have instinctually been avoiding the center of the arena. And we had to estimate the pathway angles taken by Coco, and as a result, we did have to estimate the distances per pathway. And it was possible that the pony was more motivated as it approached the food compared to being further away from it. If we were to do this experiment again, we would do a few things differently. For example, we would use multiple horses, preferably of different sizes, just to get a comparison. And we would like to use a wild horse or a less trained horse compared to a domesticated one. And we would use a dirt compactor on half of the round pin and a cultivator on the other, as to create greater differences in mediums. We would also like to use a drone video recorder to capture the angle changes more accurately. And we could use harsher difference in mediums such as grass, concrete, gravel, etc. And once again, we would like to thank Rachel and Coco the pony for their time and cooperation. And thank you to the audience for listening.